Hey gang, so this is our second scientific revolution video. And in this video, we're going to go through several scientists and we're going to focus on the changes in the field of astronomy. So sometimes students get confused. They think astronomy and astrology are similar or connected and they get it mixed up in their head. So astronomy is studying like the planets, the moons, the things that are in the universe outside of Earth, right? Astrology is studying those things like stars, etc., in order to understand someone's life or future. So you want to make sure you understand the difference between astronomy and astrology. So if somebody says, what's your sign? And you say, oh, I'm a Cancer, that's astrology. If we're talking about what are the planets like? How many moons does Jupiter have? That's astronomy. So you want to keep that straight. And what we're going to do is we're going to talk about what did people think about astronomy and how the universe was set up before the scientific revolution? And then how do their views of the universe change over time? So pre-scientific revolution, the view of how the universe was constructed was based on really mostly these ancient Greek air quote scientists or thinkers who argued that the universe was geocentric, meaning the Earth is in the center of the universe and everything rotates around the Earth. So that's what people believed. People believed this is coming from ancient times, but really up through the Middle Ages, people believed that there were these crystal spheres, that they were invisible, but like kind of like glass, but they were there, and the planets and the moon, etc., they all rotated on these spheres around the Earth. That's how things moved around the Earth. And this was considered the heavens, right? So people believe that like that's where heaven was. And they believed everything traveled, all these objects in the night sky traveled in perfect circles because the circle was the perfect shape and God designed the universe, so God would want the perfect shapes. And so ancient thinking is really the foundation for how people think about the universe, but also the church Christian beliefs, the description of the creation of the universe in the Bible, that is also fueling people's beliefs in how the universe worked. How it was configured. And so that's going to starts to change in the 16th century. So 1500s. So what else is happening at this time? The Reformation is happening at this time. New monarchs are happening at this time. We've got all these changes. The Renaissance is happening in this time, the late Renaissance. So in the middle of all of this, some people start to challenge this old view or question it or try to study it. And the first famous guy you need to know is Copernicus. So Copernicus is seen as the figure that gets this all started, this scientific revolution. He's often cited as the earliest. And he writes a book on the revolutions of heavenly orbs or heavenly spheres. And he doesn't publish it. Actually, it doesn't get published till after he dies. Copernicus was a member of the Catholic clergy. So he's a church employee, a Catholic church employee, but he also studies, right? He's been educated. He's interested in science. And so he realizes, other thinkers had realized that the description of the universe established by this guy Ptolemy is the guy that in the ancient times who tried to work out how the planets are moving around the earth and how the math works for these rotations. And people knew there were problems with that because the earth isn't in the center and everything doesn't rotate around the earth. And so Copernicus was kind of questioning, well, what happens if we try to understand what we're seeing in the night sky, if we try to understand it by thinking the sun is in the center? And that's heliocentrism. That's the heliocentric theory. So Ptolemy's view was the geocentric universe, and sometimes that's called the Ptolemaic view. And then Copernicus's question was, what happens? He's forming a scientific hypothesis. What happens if we put the sun in the center? Does what we're seeing make more sense? Does the math make more sense of how these planets are traveling, how these things we're seeing in the night sky are traveling? So that's also called the Copernican theory, heliocentrism. So it challenges the description of the creation of the universe that appears in the Bible. And so remember, this is a really tense time for religion, right? And Copernicus isn't trying to challenge religion. He's trying to help figure out how the universe is functioning. But he realizes this could shake people up, and things are already tense because the Reformation has started. So he postpones publishing his book, and he does dedicate the book to the Pope. Now, remember, we had talked in the previous video about how famous people were patrons, right? So it's not uncommon to dedicate a scientific work to a famous person, because hopefully they would want to be linked with whatever this effort was, right? So it was Copernicus's way of saying, I'm not trying to challenge the church. I'm just putting out a question. What happens if we try to understand the universe by putting the sun in the center? Now, this is really important because it's complicated. So you want to pay attention to this. So initially, the people who get most upset at Copernicus's idea initially are the Protestants. So Protestant leaders, Luther and Calvin, are going to condemn Copernicus's views. They're going to be upset because, remember, those guys are emphasizing we need to believe what's in the Bible. And so because Copernicus's theories don't seem to gel with the Bible, they're going to say to their Protestants, they're going to say followers, they're going to say, don't read Copernicus, this isn't good, blah, 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 blah. Initially, the Catholic Church does not condemn Copernicus's book. This was what he was afraid of, but it doesn't happen right away. They're thinking, it's just a theory. Monks and priests come out with theories. We've got other stuff to worry about. We're dealing with the Protestant Reformation. But eventually, remember, they published that list of books, the Index of Heretical Books. Eventually, they realized this could be dangerous. This type of scientific thinking could be dangerous. So initially, Protestant groups react against it. The Catholic Church is fine with it. But later, the Catholic Church is going to be against it. And actually, eventually, it's the Protestant countries that are going to, or the countries where the Catholic Church is not as influential, that those are going to be the places where science really advances. Because this issue is going to start to be linked with the fight against this type of new scientific idea is going to be linked with Catholicism, and the Protestant countries are not going to be as worried about it. So that shift occurs. Okay, so next guy is Tycho Brahe or Brahe. I've heard it all different ways. He's Danish, so I'm not fluent in Danish, so I'm not necessarily saying his name right, but we're going to say Tycho Brahe. So Tycho Brahe is studying astronomy. and hears about Copernicus's idea, and he is like, Copernicus is totally wrong. This is ridiculous. The sun is not in the center. The earth is in the center. So then if he believes the wrong thing, why is he in this list of scientific revolution thinkers? Well, he's in the list because of how he deals with fighting Copernicus's idea. He collects data. He has this great observatory where he can really easily see what's happening, where the stars are each night, where the planets are that are visible. And so he records all these observations and collects all this data. So even though he's trying to use the data to prove something that is not scientifically true, to prove that the earth is in the center of the universe, even though he's trying to do that, he's still helping advance science because he's collecting so much data. And his data is going to get used in the future by this guy, Kepler. So Kepler gets a hold of Bray's data. And Kepler is going to try to see what happens mathematically when he uses Bray's data of where all the things are in the night sky. And he uses the heliocentric theory, Copernicus's theories. So does the math work out? Does it look like the sun is actually in the center? And he suggests, yes, the sun, not meaning the sun is truly physically in the very center of the universe, but meaning things are rotating around the sun. Planetary bodies are rotating around the sun, not around the earth. And so he develops 3 laws of planetary motion. So what do you need to know about Kepler? You need to know he's using Bray's data. He's trying to prove Copernicus is right. He's doing mathematical calculations, and he's developing the 3 laws of planetary motion, which are orbits of planets are elliptical, not circular. So he's challenging that old view that everything is perfect. There's these perfect circles in the heavens. So they're actually ellipses. They're kind of like ovals, right? It's not circular. Planets do not move at a uniform speed. So sometimes they seem to go fast, and then they'll go slower as they move around in the universe. And he figures out the time it takes to orbit the sun is based on the distance from the sun. Now, these observations, these laws of planetary motion, we're going to later find out the reason the shape is of the pathway, the trajectory is elliptical, is because of the force of gravity. The speed changes are linked with the force of gravity. He doesn't know about gravity, but he's observing and figuring some stuff out. And so this is a major scientific development. Okay. So we're at 13 minutes for this video. I think why not stop here instead of me droning on and on about scientists. So we'll have more videos, but at least they'll be shorter, right, guys? So in this video, we've covered Copernicus, Bray, and Kepler, and we want to remember the first field of science that's really experiencing the scientific revolution is astronomy. So it's not biology that's advancing immediately. It's not chemistry that is advancing immediately. The first field that we really see big advances is astronomy. All right. Thanks for being awesome. And I look forward to talking to you soon.